is we need to come back in and we need to write the stock system name. So N is nitrogen and O is oxide. Now, we need what here? A Roman number. Now, here's the part that somebody in, I think it was third period, asked me yesterday. They said, does the prefix have to match the Roman number? What's the answer to that? The answer is no. It might. If it's been reduced, will it match? No. If it hasn't been reduced, it will match. Okay? So, has this formula been reduced? Yes. So, you have to look at O's oxidation number. And O is one I just memorized because you're going to use it so much. O has a -2. Is there a 2 right there in the formula? No. This one's been reduced. So, this prefix and this, they're not going to match. So, if there's supposed to be a 2 here, what did this formula used to be? Used to have a 6 there. So, it's Roman numeral 6. Nitrogen 6 oxide. Okay? Now, did this formula get reduced? No. Fluorine is a 1, and it's still a 1 right there. So when we write this one, it's going to match. So this is chlorine, fluoride. What number came from chlorine? And we put a 2. All right, was this one reduced? Oxygen is a 2. What number is right there? So it started as a 2, it ends as a 2. So was it reduced? No. So they're going to match again. So phosphorus, 5 oxide. The only one that was reduced was number 1 because the oxidation number is a 2, and what's not written right here? A 2. The number's a 1, it ends as a 1. It's a 2, it ends as a 2. You can see the numbers written in the formula. Questions about that? Yes or no? Sophie, I know is with me. What about the rest of y'all? She answered me. Stephanie's nodding at me.
Nope.
Samaria answered me. What about the other 14 people in the room?
No.
Okay. Phosphorus pentoxide. How do I write the formula? P I. We okay on that? Okay. Diantimony. How do I write diantimony? Sb2O5. Everybody cool with that?
Yes.
Everybody feels all right about the opening. Tiffany made a face. Why'd you make a face? What's wrong? You're good. You swear. Okay. It's just my bad handwriting. Okay. Anybody have a question about how to do this? Okay. All right, let's talk homework. All right. I'm not checking today. Let's see what you know how to do. Because I'm going to check what you know how to do in a quiz format in a minute. Let's find mine, or I'm just going to go get a blank paper in a minute. Oh, there's mine. All right, was anybody not here yesterday I need to get one for? Everybody was here? All right, so number 1, calcium. Good Lord, maybe I should write down my answers in the future. All right, carbon. Let's just do it one way or the other. Which one you want to do first? That way I don't have to switch back and forth. I'm getting old. Sometimes I don't switch back and forth as well. Let's do prefixes first. All right. So number 1 is carbon dioxide. 2, carbon monoxide. 3, sulfur dioxide. 4, sulfur trioxide. 5, dinitrogen monoxide. 6, nitrogen monoxide. 7, dinitrogen trioxide. 8 nitrogen dioxide, 9 di-nitrogen tetraoxide, 10 di-nitrogen pentaoxide, 11 phosphorus trichloride, and 12 is phosphorus pentachloride. All right, stock system. Carbon 4 oxide. 2 is carbon 2 oxide. 3 is sulfur 4 oxide. 4 is sulfur 6 oxide. 5, nitrogen 1 oxide. 6, nitrogen 2 oxide. 7, nitrogen 3 oxide. 8, nitrogen 4 oxide. 9, nitrogen 4 oxide. 10, nitrogen 5 oxide. 11, phosphorus 3 chloride. And 12, phosphorus 5 chloride. All right, what would you like me to do or talk about? I taught that so well, no one has a question about anything.
I don't get the stocks at all. I know I'm not the only one. I get it until it's like the 2s and the 1s. Like the 3s and 4s, those are easy. But when I don't see the oxidation number in the table, I guess
it doesn't matter what's on the table. The table is only there to tell you if you need a Roman number, if you're going to put it in, okay? It doesn't matter if the Roman number is on the table. For example, if you have, I hate that one. All right. If you have one like NO2, all right, and I think I picked one that I know is not on the table. If you look at that formula, okay, everybody can write nitrogen. Everybody can write oxide, I hope. Now, at this point, if you can't tell me that it ends in IDE, I don't know what to do for you, okay? How many capital letters do we have? You have 2. You have to add what kind of ending if you have 2. Add, okay? At this point, if you're not ending in IDE, you're not paying attention to how many capital letters you have. If you have something that ends with, let's just say MnClO3 with a 3, is it going to end in IDE? No. Mn is manganese. And where do you find this at? On the blue chart, right? So what's its name? Okay. So go ahead and find it, Tiffany, since you're looking. Got a little faster hush over there. All right, so you write chlorate. Now, that's easy enough to look up. So you know over here, this is going to have IDE on the end. Why? Oh, hush. Why is it going to end in IDE? That's why. Okay, and you got to do that every time. Now, the part y'all are struggling with is, do we need a Roman number right here? And then what does it come with? Okay, look up nitrogen, Jade, on your paper, on your blue chart. How many numbers are beside nitrogen? That tells you you need a Roman number. That's why I drew those parentheses in right there. It's got 3 numbers. Now cover that blue chart up. Okay? Don't look at it again. Oxygen has a -2 oxidation number. Okay? Where's this 2 have to be in the formula? When we crisscross. Okay? Every time we crisscross, where's that 2 going to wind up in the formula? at the bottom. It's going to wind up right here. But it's not there. What's the only way that 2 can go away? It's got to reduce. Okay? This right here is the original oxidation number. Okay? You are telling me when you write the name what the original oxidation number is. You're not getting that number off that blue card. So you're not looking at the blue card for what the number is, which is why I'm telling Jaden it doesn't matter what's on that sheet, okay? Not every oxidation number for nitrogen is listed on the sheet. It probably says -3, +3, and +5. Those are the most common. It's not the holy grail. It doesn't have every oxidation number nitrogen can have on it. You're looking at this formula. What number does this formula have for nitrogen? That's what's going in that Roman numeral. Okay? So, you have to figure out what is right there originally. Okay? Using your math skills. Now, I don't think this is hard because all you have to do is multiply. This was a 2. That 2's not there. Multiply this 2 through this entire bottom set of subscripts. Okay? 2 times 1 is what? 2 times 2 is what? That formula used to be N2O4. What number came from the nitrogen before it was reduced? 4. That's the number that goes there. It's irrelevant if that number's on the blue sheet or not. The blue sheet is only there to tell you, do I need the Roman number or do I not need the Roman number? It's the only function. Okay? So if I have another one, like let's say manganese chlorate, does manganese need a Roman number? How do you know? You have no idea. So now look at your blue card. What's it say beside manganese? Then it needs a Roman number. Okay? It has 6 numbers. It needs a Roman number. Okay? How do you know if this has been reduced? You have to look up what element. The ClO3. So look up ClO3 and tell me what it says. It's chlorate. What does it say above ClO3? Okay, so that's its oxidation number, -1. So it's a 1 right here, right? What's right here? So it starts as a 1 and it finishes as a 1. So if it started as a 1 and it finished as a 1, was it reduced? Okay. What did it start as here? What did it finish as here? That's a 1. Nothing's written there, it's a 1. So it starts as a 2, it finishes as a 1. That's reduced. Okay? It starts as a what here? And it finishes as a what? Is that reduced? No, that's the difference. So this one was not reduced. Okay? So you don't have to do any of that, figure out what it was crap here. So what number in this formula came from the manganese? This came from here. So this came from here. So manganese is a 3, and we're done. Okay? Not every formula will be reduced. You have to figure out which ones are and which ones aren't. Okay? So if I have one like this, which throws all kinds of people off. Okay? Suppose I give y'all this on the test. Throws all kinds of people off. And I want y'all to write the name. All right, what's the name of it?
Sodium
Okay, sodium. Everything after the sodium, all of this stuff after the sodium, you look up together. All right? Samara, you hush. All right? What do you do, Jade? All right, so you write oxalate, right? Do we need a Roman number? How do you decide, Jade? No. So you're done. You don't have to do anything. Because everything after that Na, you just look up as one thing. You don't write carbon and oxygen and all kinds of other weird stuff, right? You're just done. Now, what if I change it up? All right? What if I do this? How does this make it different? Okay, this is copper. All right, it's still oxalate. All right, now what? Okay, now I need an oxidation number. So are you trying to tell me I need a Roman number? Okay, so what oxidation number, Roman numeral am I putting in there? What? Why am I putting a 1 there, Stephanie? Huh? That's what? I can say it loud enough I can hear you. All right, why is it a 1? Why isn't it a 4? What tells me it's a 1? Uh-huh. How do you know?
There's nothing on this one if there's a 1 on here.
Okay, I agree with you. I just want you to tell me how you know that. Why is it at the 4 is what I want you to tell me. I'm not saying you're wrong. I want you to tell them how you know it's 1 and not that 4. Because you are correct. I'm not saying you're wrong.
Why did I explain it?
Because some of your classmates on test day would say 4 instead of the 1 that is correct. That's what I wanted you to say. All right, you took the parentheses off, and you see that in your head. You're just not telling me that. Okay? You have the right answer. All right, so there are parentheses here that Stephanie has taken off in her head. Okay? So, because the number outside of the parentheses is a what? A 1, Stephanie took those off. So, if the parentheses have a what number outside? If this is a 1 and there's a 1 outside, are we required to keep the parentheses? No, we're not. Okay? So, I wrote it as Cu C2O4. Now, look up oxalate on your blue sheet. That 4 is part of the what? It's part of the ion. As long as that 4 belongs to the ion, it is not part of that polyatomic ion. It can't go with that. Okay? Oops, I left the 2 off there. Okay? Now, as long as that goes with the ion, it's not part of the oxidation number. So what she's saying is that parentheses took care of that. So that 1 is way out here that we took off is the oxidation number. Now, we talked about this way back when we talked about ionic naming. Even though it's an oxidation number of 1, can I leave that Roman numeral 1 out? No, because remember, you're telling me what? I had it written down somewhere. Let's be back one more. You're telling me the original oxidation number. You're telling me what oxidation number to use. So if you want it to be an oxidation number of 1, you have to tell me that. Does that help at all with the stock system? I mean, that's what it is. But that's how you do it. You have to tell me the oxidation number. Yes or no? Okay. Anybody else? Question? Yes? No? Okay. You need a writing utensil, and you can even keep your oxidation sheet today because there are no acids on it. Remember, you keep your blue sheet today. I told you, there's no acids on it. You can keep yours. Put the rest of your crap up. Your dash should look like Sophie's. Blue card. If you got a calculator for later, that's fine. Make sure I can read your handwriting. There's one typo I need to tell you about in number 10. Got the typo. I need to tell you what the element is. You're probably smart enough to figure it out, but I'll tell you which one it is so you're not looking all over the periodic table. All right, does everybody have a quiz paper? Number 10 says carton. That's supposed to be what element? It's carbon. Okay, it's carbon, not carton. All right. Where are the questions at numbers 1 through 4? Say stock system. You have to write them in the stock system. You cannot write them in old or prefix system. Those first 4 have to be in stock. Questions 5 to 7 have to be in old system with the prefixes. And then, of course, the bottom 3 are asking for the formulas. Any questions? Okay. Once you're done, flip it over. Old is the prefix system. Okay? Old is the prefix. Stock is the Roman numbers. You need the water. Sure. How many people do I have still working? Anybody? I can't tell at this point. So we're done? All right, press purpose to the front.
I'm still working.
Oh, never mind. Scratch that. Since it's just Celia, tell me when you're done. Okay, press purpose to the front. All right, before I give you a worksheet, let me see what I have before some of us mutilate this. Jump.
I should smash.
I'll just make something up. All right. Before I give you the worksheet that has everything mixed, okay, the section that's going to cause the issue, all right, will be the top section, the bottom section. I can't remember which section it is, but it's the one that says write the names. Okay? Now, why is writing the names going to cause the issue? Let's say, for the sake of argument, let me look at the sheet so that I don't give you the same examples. I won't pick any of the same ones. Let's go with and one more. I already did one of those. All right, so let's say that these are the 5 you have to write the name for on the worksheet. Okay? And it's just a hodgepodge of names. Now, on the previous assignments that you've done, I've said write in stock system on the quiz. Write in old system. Now, you're being set forth on the assignment today. Write forth in any system you wish. On the test, write in any system you wish. There are exactly 2 questions out of the 22 that I will say. One says write in old. One question says write in stock. The other 20 questions, you may choose. Okay? I will not say. You must. You choose. Now, are all questions able to be written in either system? No. You must choose appropriately based on which is allowed. So how do you decide which is allowed before I set you free to do this in a moment? Whether it's a metal or non-metal, I heard that. Whether it's covalent or ionic, excellent answers. So how do we decide? In case some people are unsure, because not everyone is on the same page. Sounds like the vast majority of us are. So in the top one, SI 4, how do we decide? Okay, so just tell us what you think. All right, it's a non-metal. So what would we do, Jade? What are my options? We can use the prefix on that one. All right. So you would have options on this one of prefix. Is that the only option we have? No. You could use prefix or stock on this one. All right. What about the second one? Why? So no prefix on that one. All right, Xavier said only stock, and then he double checked himself, and he's like, yes, just stock. He is correct. Don't doubt yourself. Use your skills. You are correct. All right, he can only use the stock on that one because it has a what right here? What's that? It's a metal. He is correct. He may only use the stock system. All right. What about the third one? Stock only. It's got a metal. Okay. Starts with a metal. Stock only. All right. SNS2. Okay. Now, am I checking the entire compound? What am I checking? The very first element. Your metal is always front and center. It's always the very first thing. If it's not first, is it going to be a metal? Okay? SBR2. There you go. Prefix or stock. Everybody good with how you decide?
So basically, you could do stock and different anything.
Yes, you can. Dang. Why do you think I pushed it so hard at the front end? Okay, everybody loves prefix, but you can't go wrong doing the stock system, except for one question on the test, which is 2 points. One question on the test, which is 2 points. And maybe one other that I wrote in stock. So a total of 4 points. The vast majority of your exam, the vast majority of this course will be written in what style of naming? Yes. The modern style of naming. Yes.
Okay, so like I get how to do the math and everything, but what is like oxidation number mean?
We're going to learn that as we cruise through the course. Oxidation number is basically the number of electrons that an atom loses or gains in order to get to 8 electrons in its outer shell. So when we talk about bonding, for example, let's say Sophie and I want to form a compound. Okay? Sophie's got some electrons. I have some electrons. Let's say she's got 1 in her outer shell, and I have 7 in my outer shell. Okay? She can lose 1. I can gain 1. And by doing that, she can get 8 in her outer shell. I can get 8 in my outer shell. So she gets a +1 oxidation number. I get a -1 oxidation number. No, it doesn't. But we'll talk about all of that as we. Some teachers teach that on the front end. I teach it on the back end. That way we can re-loop it. There's a big concept in education called re-looping, and I teach it in a different order. It works for me because I think it's boring as crap to start the course that way. All right, so we're going to try mixing it up. You can name it any way you want. If it's covalent and you want to name it with old system, by all means, go ahead. I will call out the answers both ways. If you prefer, as some of you have figured out, you mean we can always use stock, knock yourself flat and name it in the stock system. All right? We're going to take about, time is it? No, we're not. Let's say 20 minutes tops. We got some math to learn today. We are not taking 20 minutes or 30 minutes. All right. I wonder if I did the answers. Let's say, because I can let you check, but sometimes it's easier just for me to walk around and look. What's the first compound on there?
Calcium iodate.
Yes, I even got the answers written down. Half of these are blank, but I got that one. Anybody have a question for me? Stuck? Won't help? They pay me to answer questions, you know. And grade papers later. Question? Yeah. Just amused by my commentary. Jay, question? Just disgusted by my class. Well, I can't fix that. And so who do you have to get through to get to where you want to be later in life? You sound like my daughter at the kitchen table last night. You don't like her chemistry teacher?
I mean, it's not that I don't like you, I don't like this, I don't understand it at all.
Again, it's just a hoop. Try to get where you want to go. I'll be glad to help you if you want me to see it. Yeah. Yeah. Okay, the only issue you have is the other says iodine. Okay, you said iodide, that says iodine. These two things match in full. That's just not the compound I gave you. So go get your blue card and come back. All right. All right, so, culture. So you can find iodine. Okay. So instead of just putting in I, you want to put in I read it. With a negative one, but over here. I read. Just like you have here, so they did all parentheses. You go negative one right there on each side. Same thing. Same thing. Now, rewrite it like you did here. Do it without. And the next one's right too. Good. Jay, bring me what you got. I said, bring me what you got. Mario, when you write your Roman numerals, don't write them really tiny. Put them in between the compounds like the mean for the B there. You understand what I'm telling you? Okay. You know how you got like silicon oxide, you had a little itty bitty Roman numeral right at the same size as the rest of the words. Okay. All right. So, when you looked up this, what's his oxidation number? Mm-hmm. There's two. Okay, so there's two right here. What's its oxidation number? One, there, no need matter this negative. So, this two, over here. No one. Bring it over here. Now, rewrite what you've got after you crisscross. You can use this as a subscript, it's not line. So you can down here. Good. Let's do the next one. So put your parentheses on. Perfect. So the next one.
The oxidation goes rotated, it's a free. Good. The next one. Good. You get the hang of it? Okay. Next, so now this one has dioxide. This one is cold system. So this one is not going to crystallize. Okay. And we'll do the prefixes equal subscript. Okay. Who else has a question for me?
I can get confused.
All right, you good on this one? What is the oxidation over tungsten? Tungsten. All right, what's that? All right, so that's a 6. That's what happened here. Okay. All right, CR, this means what? You don't have all the No, that means that is 3. That means when you write this down, you write 3 right here at the top. It's not the first number, no, it doesn't mean multiple numbers, it means that's 3. You don't have to look at Chromium on there, you only have to look at the sulfate.
This is wrong with that.
Yeah, always forget that. Waiting for the 6. Always. Oh, no. Just on. See, on that one too.
See, what I'm trying to figure out is how you do number 5. See, because you have S2O2. So I'm trying to figure out how
Oh, I
to do
guess because
this.
it cancels out.
I'll ask her, you know.
I need you to have these.
Oh, yeah, that's
That would be bromine. Yeah, that's all the numbers. Last. Negative, that's right. Because it's negative, it has to be. Last, it has to be negative.
So,
Okay, so this one, this is your line. Okay, so there it's old system. Prefix equals subscript. Let me crisscrossing that. The prefix equals a subscript. There's no prefix. That means 1. And so there you go. There's no crisscrossing there. All the rest of them here, see how they have the Roman numerals and all that? You're gonna need to crisscross. All the rest of them. There's a rolling stock system. Got everything right?
Oh, she said she was gonna do it this week and next week for what? For Gomez.
She was making lunch this week and next week, so we either go 3 times or 3 times a day.
Also, it's every other week.
Yes. So she said it's for next week, so it was this week and next week, and that already is, when we get it, when we get our, whatever.
Yeah. You'll need to go 3 times.
3 times this week.
I know.
Oh, yeah,
I
that
was
was
today and tomorrow, but I ain't going today.
Oh my gosh.
I'm gonna go tomorrow.
I was walking in, I'm so tired.
She wants to say it's okay.
Stop. I was about hoping she's running next week. It was like, everybody used to.
I'm gonna be answering a bunch of them because this company's still having out the list. And she was just like, I don't know what you're gonna do. Also, she said,
I was like, yeah.
yeah,
That's too expensive to do at school.
she and kids have been very, yesterday, going over it and everything like that. And then we have to, those 2 days on the week is gonna do it too.
That's all right.
Wow.
Now you got what tonight. And you can do them all in stock and not have to do them in old system. All right, we're right at about the 20-minute mark that I gave you. All right, seriously, we're at the 20-minute mark. I know, it's hard to imagine, isn't it?
Is it just me, Jake, or is this hospital last week like a 100 years?
I don't, as long as it lasts the day.
No, this class goes long. It's like psychology, secretary. Like try having this conversation.
Oh, no.
She's on my nerves.
Yep.
Oh, Darby. Okay, hold on. So, I was right. We're gonna find
So yesterday she was sad because her cat was at the vet. Just how she was bad, and he told
The what?
Yes, I was. Yeah, either way it goes.
You gotta keep these two straight. MG is the name, these are classic. Because as soon as you write name and ease, it's
She was
wrong.
following the fast.
Alright, that's a parentheses, what's name of that? So write phosphate. Alright, how many oxidation numbers does magnesium have?
She's always saying.
So does it be
Her
wrong?
hair is long.
You're not. She walked past that nice Alright, if you haven't finished the naming sheet, can you finish it for homework? I know, it's a dirty word.
That's
Okay.
very, very bad word.
Yeah, I'm trying to look up the number again for you if you don't have it.
For heated problems.
Yesterday.
I have a feeling not for Jessica.
I haven't did anything every time. Oh, what were we supposed to do?
The,
Was it the math?
yes,
Did you do it?
yeah, I think you said just label it, so I just labeled it and then colored it in color. Is that, he didn't
Let
want
me
to
see it
see
so I
it.
can take a picture.
Oh my god, I got them all right. Except for one. Take that back.
Oh, except for one.
I'm coming home.
Right.
Ms. Wall,
Yes,
do you have LaShonta Hopkins?
I do.
Can you send it to the ninth grade hallway, please, to see Mr. Mumford?
Yes,
Thank you.
you're welcome.
Miss Cornell, let's get you yesterday.
Man, good. I seen her after school, she was just like, I almost hurt you everything.
She looked really furious, and I was like, dang, what was she gonna do?
Here,
She got her
here's
hands on you.
Man, yes.
Right.
She takes me to my bed.
If you did not finish the naming worksheet, finish it for homework, okay? I will be here this afternoon if you need help, okay? I'm here. Come see me. You don't just have to come for test corrections if you need help. Now, for the remainder of class, we're going to work on some math that goes with naming. There we go. So, we're going to talk about formula mass, molar mass, molecular mass. I have even seen it called gram formula weight. Now, all of this means the exact same thing. All right, it depends on the author of the question or the text as to which one they call, but it all means the same thing. It is the mass of a compound. Now, if you think back to about a week ago, we were only finding the mass of elements. You were looking up the atomic mass of an element on the periodic table because we only knew about atoms a week ago. You were finding the number of protons, the number of neutrons, and the number of electrons, because that's sort of where we were at that moment in time.
So that all means a mass.
Mm-hmm. Yep. What you could call it a formula mass, you can call it a molar mass, you can call it a molecular. I left molecular mass off. Molecular mass. All right, gram formula weight. They all mean the exact same thing. Well, that was quick. All right, it just means the mass of a compound. Now, we've learned in the last week how to write the names of compounds, right? So we're ready to branch out into our calculations now that we've gotten more sophisticated. And as we get more sophisticated, our math will become more sophisticated. What we're getting ready to learn to do is one of the easiest math problems we will do this entire semester. Okay? It is super easy. Does everybody have that? All right. So let's take the molecule that you guys used in biology class. Let's take glucose. Okay? And we're going to calculate molar mass. And I will change the way I refer to it, just so you get used to seeing a variety of ways that it's referred to. It all means the exact same thing, though. Okay? Now, when we say calculate the molar mass of the compound, last week when we needed the mass, we just looked up at the periodic table and said, oh, the mass of carbon is 12.01, and we wrote it down. Well, glucose can be found on the periodic table. We can't look up there and go, oh, glucose mass is 180 atomic mass units. It doesn't exist that way. So how are we going to find the mass of glucose? What two things do we need out of that formula in order to find the mass of glucose? Think logically. What would you need to know in order to find the mass of glucose? The elements in it, okay. What else about it?
How much?
What do you mean by how much? Their masses, that's one thing. Okay, we need to know their masses. So what else do we need beside their masses? The what? The number of them, okay? So we have what, 3 elements? Carbon, hydrogen. All right, so you said we need their masses. So what's the mass of each? 12.01, so I'm just going to label atomic mass above it. Typically, we write that as 1.01. We just round it up. All right, and oxygen is?
16.
All right. This periodic table uses 16.0. Some older periodic tables use 15.9. So I'll try to remember that y'all says 16.0, but I've been using 15.99 the vast majority of my teaching career. So if I write 15.99, don't hold it against me. All right, so the atomic mass. And as y'all get better at finding the elements and navigating the periodic table, I'll begin to just write them up there. But right now, y'all need to learn how to find them on the table. And the more practice you have, the faster you get at it. It's always easier to tell who does their homework and doesn't, because the slower people are usually the ones who are not practicing. All right? Now, you said the number of each element. So, how many carbons do I have? And the number of H's? And the number of oxygens. Okay? I believe that's 72. That'll be 12.01. I think. Whoops. 72.06. Let me multiply that. I usually just use whole numbers. It's easier for me to just use whole numbers. We're going to use whole numbers. 96. All right. 180. Now, what unit did we say that these were going to turn out to be when we found average atomic mass last, I don't know, Thursday, Friday, last week? AMU. So, for you. So today, when we calculate molar mass, these are still AMU, or you can write U. Either one is still acceptable. Doesn't matter which one you use. Now, you can tell who Marissa's friends are. She walked around a hand calculators out to start figuring.
Why?
I meant to only single out the guys, Jade. I didn't mean to single out you. All right. Everybody got what they need. Now, the only thing that makes this slightly different is we also encounter compounds that are like this. These compounds also have parentheses. So you have to do exactly what you would do in math class. What again do parentheses mean in math class? Distribute in times. So when you add up your atoms, sometimes chemistry students get careless and forget that they multiply and distribute. So how many CAs would we have? Okay, let's go back to some basic math. Okay, this 2 is distributing to what? The parentheses. Is the CA in the parentheses? No. So the CA is going to have what? The CA is only going to have 1. The 2 is only going to distribute to what's in the parentheses. So the 2 goes to the what? Cl. And then the 2 goes to the oxygen, which will give you 6. Okay? So that's why I wanted to point out one with parentheses. That's as hard as these problems get. As long as you can do that, you're home free. All right? Mass of calcium first is
40.08.
and chlorine
35.
and oxygen. What's that? 32, 32, and 32, 96? I don't know that one off the top of my head. Got a calculator for me yet?
Sure.
206.8. Now, the nice thing about this is you only get a compound. So, will there be any significant digits in this kind of question? Okay. There are no numbers given. So, there are no significant digits. Okay? Because there's no numbers given. There's no significant digits. So you don't have to worry about significant digits or the loss of points with these kind of questions. So that's kind of cool. Make sense? Yes? No? Because I just said calculate the mass of calcium chlorate. I didn't give you a number to go with it, right? Okay. Now, you remember that quiz that everybody scored 95 or higher on? Remember grams, moles, atoms? Everybody did really well on the charts. The only thing people lost points for were units and significant digits. We got to do some more with those charts. Okay, that's what we're going to finish our lesson with today. All right, so we're going to add on to our chart. So you remember when we said 1 mole was equal to 6.022 times 10 to the 23rd atoms. Okay? And I talked about the example of eggs. And I said small, medium, and large eggs. Now we're going to branch out and I'm going to write it down. Okay? Now, if I said Tomas ought to buy a dozen eggs, and I said Andy ought to buy a dozen cupcakes, and I said Tiffany ought to buy a dozen brownies. The eggs, the cupcakes, and the brownies. How many would I have of each? 12. Some of you would be really excited about the cupcakes and the brownies. A lot of us would be really disappointed if I handed you an egg. A raw egg? Some of you might take it because you can take it home and cook it. Some of y'all would throw it at some people and be like, woo, I got eggs somebody today. Some of us would be pretty excited that we got a cupcake or a brownie. But in the container, there'd be how many of each? 12. Now, today, we're going to branch out. Okay? A mole can also equal 6.022 times 10 to the 23rd molecules. I don't care. They're your notes. I don't tell you to write anything down. And formula units. The only difference between molecules and formula units is molecules are covalent. And we'll talk about this later in the semester. Molecules are covalent and formula units are ionic. For the purposes of what we're doing today and what we're talking about, do you have to know the difference? You do not, okay? Now, the second thing we're going to talk about is we learned that 1 mole was equal to atomic mass in grams, right? Well, today, we're going to branch out just a little bit. 1 mole is equal to molar mass in grams. Now, before you guys all wig out on me, because some of y'all are thinking this woman has lost her mind. Jade's over there going, I don't ever need this stuff in my life. You're right, you don't. If you're not going to be a science person. Now, we already said grams can go to moles, right? And then we said we could go to atoms. Where are we going to put this molecules and formula units in our flow chart here? Uh-uh. Uh-uh.
After grams or after
In between moles.
Oh, it's atoms. Oh.
Now, notice the way I abbreviated formula unit. I labeled it F unit. For obvious reasons, let's not write FU. Okay? Just write formula unit or F unit. Okay? No. F unit. No, I gave you the correct abbreviations. Now, some of us changed molecules on the quiz down to M, and I told you, or moles down to M. That can only be abbreviated. If you want to abbreviate, here are the abbreviations. Moles can be abbreviated MOL. Molecules can be abbreviated MOLC. You will find that I will not abbreviate these very often, simply because my handwriting is bad, and I know that. Okay? So if I abbreviate MOLC, what do people think I wrote? They think I wrote moles. Okay? You can abbreviate moles to MOL if you want. Molecules is MOLC. Atoms does not have an abbreviation. We don't write AT or A. A stands for angstroms. Okay? Now, does everybody have that? Uh-huh. Okay. So, suppose I say, how many grams are there in 12.75 moles of Na2SO4. Now, does that question look familiar?
Yes, very.
Yes, it should. It should look very similar to what we did last week, that y'all all did fabulous on the quiz. There is only one thing that's different about this question. This was an element last week, and today it's a compound. That is the only thing that's different. This would have said Na last week or S last week. It would not have been a compound. Okay? So last week on the quiz, what would you have done to do this? You'd have drawn a chart. All right? What would go on the top line of your chart last week? Still does this week. What goes on the bottom line of your chart? What goes on the top line of your chart? Nothing has changed. Everything is identical. What goes beside moles? Still does today. It will change when we learn to balance equations. Okay? After we do some math for about 3 days or so, we're going to learn to balance equations. Okay? So it's coming where we're going to start changing these moles. We're just not there yet. Okay? Grams. We would have looked at the periodic table, written its mass in, right? We can't look at the periodic table and get Na2SO4's mass, can we? What are we going to do? Got to calculate it. What we just learned to do. We just learned to calculate it. So off to the side, you're going to say Na equals, how many Nas we got? How many S's we got? How many O's we got? What's the mass of Na?
22.9.
Sulfur
32.07.
and oxygen is 16. So that one's going to be 64. That one's going to be 32.07. That one's going to be 23 times 2 is going to be, what, 46. I'm not going to use that 0.07 because Miss Wall's lazy. That's going to be a 2. Carry my 1. That's going to be 142 U. 142. I don't have to use a calculator. All right. So that's what I get on the calculator. This time, did I give you a number in the question?
Yeah.
So this time, I need significant digits. So I have how many here? 4 significant digits. I need 4 there. How am I going to make it 4 significant digits? I can either say 1811 grams, or for those of you who just drop off, I can put a decimal behind it and put grams. I can do it either way. Okay? As long as I have 4. Questions? So what?
So we can just round like that, or
What do you mean exact?
like you rounded 22 times 2.
Yeah, you can do it either way. Yeah, it doesn't matter. Our answers are going to vary a lot depending on how you do it. Some of you, after a couple days of doing this, will round all of your numbers to whole numbers. Some of you will keep every number on the periodic table. It will vary over time. 9 times out of 10, I'm going to round to whole numbers when I do it on the board. I usually keep the decimals when I do an answer key for the purposes of worksheets or tests and things like that. But on the board, I can multiply and add so much faster with whole numbers than I can with decimals. I'm like y'all, I just don't do decimals well in my head. Okay? Questions? All right, let's do one more, and then we're going to stop for the day. All right, suppose I say how many molecules are there in 5.91 grams of SO2? Fix that S. All right, what do I do first? All right, 5.91 grams goes on the top line. Okay, what goes on the bottom line? Okay, from a gram, what is the only thing I can go to from a gram? A mole. Okay, remember that fancy flow chart we drew right here? Grams goes to a what? Moles. Moles goes to what? Atoms. Now, atoms, molecules, and formula units are the same. They're in the same position on this flow chart. The question asked us for a what? Molecule. Molecule is the same as an atom in terms of where we are in the chart. So, I'm drawing another section. What goes on the bottom? And on the top, I'm going to what? Molecules. All right, we have learned what goes beside moles. 1. We have not learned to balance yet. Molecules works just like what? What have we learned goes beside an atom? Avogadro's number. So what's going to go beside molecules? Exactly. Now, beside grams, what goes beside a gram? A compound. Can I look up there and get SO2? No. Every time you have a gram, it has to be the atomic mass. So you have to add up SO2. So S has a 1, O has a 2, sulfur has a mass of 32. I'm going to use whole numbers. Oxygen is 16, 32, 32, for a total of 64. So I put my 64 there. Okay? Now, how many significant digits do I have to have in my answer? Gotta have 3. 5.91 times 6.022. I get 5.56 times 10 to the 22nd molecules. Okay? Now, you might have slightly different than I do, depending on how you rounded that, but it should be close. It doesn't have to be identical. Okay? If it's not identical, that is A-okay.
So even for these, we have to do the times, tens, and the whatever, right?
If you use atoms, molecules, or formula units. Okay? I'm going to give you a couple of these to try tonight. Okay? So you got to finish your name and worksheet if you didn't. I know several of you probably have class better done. So it should not be a hardship to do a few math problems tonight. Huh? It's a hardship. All right, I'm going to tell you what you're supposed to do. Don't put it away so you can circle it.
Don't bother me.
All right. I want you to do number 1B. Okay? 1B. 1B. Let's do 5B. Let's do 6B. 7B and 8B. So 1B, and then I did 5 through 8B. 5B, 6B, 7B, and 8B. That's 5 problems, right? Okay, that's what I want. No more than 5.
Under problems, right?
Under problems, yes, not applications. We're just trying the easy ones right now. 1B and 5 through 8. B only. And put your calculators up. All right, I'm going to scan.
She was with it. Everybody got to know about it. If it was that much, I don't know if she figured it out. She said she was going to write you up for something kind of.